Alright, tonight's part 2 of the applications of equations. The previous video covered the first 3 topics, and now we're moving on to the last 3 topics tonight. Okay, first we'll handle a mixture problem. In a chemistry laboratory, the concentration of one solution is 10% hydrochloric acid, and that of the second solution is 60% hydrochloric acid. How many milliliters of each solution should be mixed to obtain 50 milliliters of a 30% hydrochloric acid solution? So the question is asking us how many milliliters of each should be mixed to obtain this result. So once again, we'll identify our variables. We'll let x represent the number of milliliters in the 10% solution. So this means that 50, because that's the total that we'll have of the milliliters right here, minus whatever we have in the 10% will equal to the 60% solution milliliters. I also know that these two things together, added together, have to equal a 30% solution of the total that we have. And 30% of 50 is equal to 15 milliliters. Therefore, we have the following equation. 10% of the milliliters in the 10% solution plus 60% of the milliliters found in the 60% solution must equal 15, a 30% solution of the 50 milliliters. And now all that remains is to solve this equation. First, we'll distribute the 0.60 to the parentheses right here. Doing so yields this result. 0.10x plus 30 minus 0.60x equals 15. And next we'll subtract the 30 and we'll combine the like terms on this side. And that gives us a result of negative 0.50x equals negative 15. And once we divide, we get x equals 30 milliliters. Remembering that x represents how much I need of the 10% solution, that means I need 30 milliliters of 10% solution. And since I have a total of 50, I need 20 milliliters of the 60% solution. And so there in the green box to your right, you have your final answer. Okay, next is uniform motion. It says if an object moves at an average velocity, the distance covered in time is, sometimes this is referred to S equals VT, where S represents distance, V represents velocity, and T represents time. Other times you'll notice this as distance equals rate times time as well. So looking at our problem, it says Timothy, who is a long distance runner, runs at an average velocity of 8 miles per hour. 2 hours after he leaves your house, you leave in your car and follow the same route. If your average velocity is 40 miles per hour, how long will it be before you catch up to Timothy, and how far will each of you be from your house? Alright, to help us in this problem, I've created a little table for Timothy and for you. We need your velocity, we need the time, and the distance. So I know that the velocity for Timothy is 8 miles per hour. I also know that your velocity is 40 miles per hour. We're going to let your time equal t, and Timothy's will equal t plus 2, because that takes into account the 2 hours that he's already been running. And now remembering our formula, distance equals rate times time, or distance equals velocity times time, I know that Timothy's distance is 8 times t plus 2, and I know that yours is 40 times t. And now, because you're going to travel the same distance, because eventually you're going to catch up to each other, we can come to the following conclusion for our equation on the next slide. Because the distances are the same, I can say that Timothy's distance is equal to your distance. And now we have an equation that we can solve. By distributing the 8, we get 8t plus 16 equals 40t. Subtracting 8t from each side, I get 16 equals 32t. And then dividing by 32, I get 1/2 equals t, where our time is in hours. So what this means is if you get in your car 2 hours after Timothy leaves, it will take you a half hour to catch up to him. Now to get the distance, you can use either one. You can use the 40t or the 8 times t plus 2. I've got it written out with the 8 times t plus 2. If I take my half and put it in here, I'll get that the distance is 20 miles. Our next question deals with constant rate jobs, and those are jobs that are performed at a constant rate. Our assumption is that if a job can be done in a certain amount of time, then part of that job is done in part of the time. And so we're going to look at an example. It says at 10 a.m. Susie is asked by her father to weed the garden. From past experience, she knows this will take her 4 hours working alone. Her older brother can do the same job in 6 hours. And since Mike wants to go golfing with his friends at 1, their dad makes him help Susie. Assuming no gain or loss of efficiency, when will they finish if they work together? And will Mike make it in time to go golfing? Okay, so we know that from the problem that it takes Susie 4 hours to do the job, which means that in 1/4 of an hour, she can do 1/4 of the job, as we have here. Now it takes her older brother Mike the same job. It takes him 6 hours to do. So it means that in 1 hour, he can do 1/6 of the job. So if we let t equal time, I know that in 1 hour, 1 over t of the job gets done. So now I'll move to a new slide for the remaining of the problem. So in order to get, based on what we've already known, we know that part of the job done by Susie in the hour plus part of the job done by Mike in the hour will equal the whole job done within an hour. And so here's what that looks like mathematically. So again, we have the part done by Susie in an hour, the part done by Mike in an hour, and that will equal what they do together in an hour. So we have Susie's part, which was 1/4, added to Mike's part, which was 1/6, and all that together should equal the whole, which is 1 over t. Now all that remains is for us to solve this equation. So combining my like terms here, I get 5 over 12 equals 1 over t. And now if I have 1 over t and 5 over 12, I can just take the reciprocal of each side, which would give me t equals 12 over 5. Now remembering time is in hours, I need to convert this to a mixed number. So 5 will go into 12 twice with 2/5 left over. And 2/5 of an hour, I would be 2/5 times 60 for the minutes. And that would give us 24 minutes. So this is going to take them 2 hours and 24 minutes together. And going back to the problem, you'll see that they started at 10. And so from 10 plus 2, almost 2.5 hours is about 12:30. And so Mike will have time to go to his golf game. And I'll see you tomorrow.